I'm a research scientist in the Climate Research Division, and our division does a lot of different research on the Earth system, and my particular responsibility is on the cryosphere. So when we say cryosphere, we're talking about areas where water is frozen, so snow, ice sheets, things like that. So I do most of my research on snow. So snow is important for two main reasons. The first is the water resources point of view. So snow stores water in solid form in some places in Canada for a month or two, other parts of Canada for up to 10 months. So that's, it's a really important part of the landscape. It stores that water in solid form, and then in the spring, that water melts, it flows into our rivers and streams, and we use that water for many different ways, in many different ways. The second reason snow is important is that it's really bright. So when you're outside in the winter, you know this, you put sunglasses on, it really makes your eyes feel better. And so what happens then is snow reflects energy from the sun back into space. And what that does is actually helps cool our planet. So snow provides really a cooling influence on the global climate system. So that's why we have a bit of concern about the amount of snow that we're losing, and the time of the year when we have snow on the ground, it's getting shorter. So what that means is that this cooling effect of snow is gradually getting smaller and smaller over time, which contributes to further climate change, further global warming. So when it comes to the energy balance, when it comes to the water budget, those are two of the main reasons why snow is important. To monitor snow or sea ice, we use satellite data. So we have instruments orbiting the Earth in space, making measurements, and we need to go into the field occasionally to make sure we're interpreting the satellite data correctly. So we make measurements of the snowpack, how deep it is, how dense it is, the different layers in the snow, the shape and size of the snow crystals themselves, and we can use that information to help us analyze the satellite data. So that's the kind of work that we're doing here, really, is getting into the north, making measurements that helps us understand the data we get from space. So climate models are really important because they're the main tool we have to project out into the future and tell us what we can expect from climate change and from other events that are happening in our Earth system. So these models are really important. And so what we do is we try to understand the historical performance of the models, because that gives us confidence in how they would project things out into the future. So we have many decades of satellite data. We can look at snow cover, for instance, look at how the climate model simulates snow cover, compare it to the satellite data, and that gives us some confidence that what the model is doing is correct. And so then we can look at data out to a century from now and look at how climate change will impact any part of the Earth system. The main thing the models project is a shorter period of the year when snow is on the ground across the whole country. So in the Arctic all the way down to southern parts of Canada. So what that means is that in the fall, when snow first falls, is shifting later in the season, and in the spring, when snow melts, is shifting earlier in the season. We're seeing more rain on snow events. So that means we have snow on the ground in the winter, but then temperatures go above zero and it rains. That changes the snowpack a lot. So really we're seeing a lot of changes in the seasonality of the snow and changes in kind of the structure of the snow because of rain on snow and other types of events like that. So it really is changing a lot. And so one of the very practical things is that when I was younger, we used to go to the Arctic in May. That was a month when we did a lot of measurements of the snowpack, because it was not that cold, but we were guaranteed to having dry snow cover because we want to measure the snow before it melts. Gradually over time, we've had to shift our field campaigns earlier and earlier in the season to make sure that we're getting into the field when the snow is dry and before it's melted. So now we've shifted it to April, depending if we're in the southern Arctic or the subarctic, maybe even March. So just from a planning point of view, climate change has had an impact on when we work in the north. And sort of a catchphrase we often use is, what happens in the Arctic doesn't stay in the Arctic. So all of these sort of climate-driven changes that are happening in the north actually impact people everywhere around the globe. I think the main thing is this energy budget aspect I talked about already. What happens when you lose snow cover is it sets in motion what we call a positive feedback. That's a sort of climate science term, but it just means that as you lose snow, it contributes to further warming of the climate system, which means you get less snow, which contributes to further warming of the climate system. So you can see one change reinforces future change in the same direction. So we see that a lot with this positive feedback involving snow cover. I think the other aspect is important. Again, it comes back to water. So in Western Canada right now, we have very low surface water supplies. That's because we've had below normal snow cover in the winter, and so there's less snow melt to recharge that. So we really need to think a lot about the water resources that we get from snow, how climate change is affecting the seasonality of that, and how it affects human use of that water. I think it's really important for people to realize that individual actions, if everyone does them collectively, can add up to something significant. So if we think about how we travel, how you get to work, how you get to school, it may seem like a small thing, but think about that. Try to reduce your carbon footprint. Think about the food you eat and where it comes from. Little things like that maybe seem small, but if everyone thinks about it, the collective action actually means something. And I think with climate change, we have to think a little bit about how the actions of individuals matter, but also the actions of communities and the actions of countries. So we need to come together, at a very large scale and work together to solve challenges related to climate change. And I'm old enough to remember some previous challenges like acid rain or the ozone hole, where the international community had to come together and solve these really big, challenging problems. And the outcome in both of those cases was actually quite positive. And so the question is, can collectively we do the same thing for climate change? And so it's a challenge. We can't diminish the scale of it, but I always try to think positively and think, well, we've done this collectively in the past. We should have our best interests at heart. So hopefully for climate change, the same outcome happens in the decades ahead.